Just to give you a perspective, my background before I went to ICTP, I was born and raised in a very small town called Gdami. It's about 700 kilometers from the capital. It's in the westmost of Oromia region of Ethiopia. The condition I grew up in were very far from ideal. We didn't have enough books beyond the standard classroom textbooks. We didn't have even a table to write on in our classrooms. There is a little promotion of fundamental sciences. After I came to MIT and talking with many students, I realized that students from more developed countries are introduced to physics and the fundamental sciences from early on. Like even in their primary and high school years, they knew what they want to do, even the particular research area they want to do. That was not the case for me. I didn't have that experience. I didn't even have a computer until I joined the university in Ethiopia. There were no books on popular science or physics, and on top of that, there's a lot of pushbacks against people who want to pursue those fundamental sciences, those sciences for which you cannot see the result immediately. But growing up, I liked mathematics and solving equations, but it was only in my last year of high school that I heard about quantum mechanics, and then I fell in love with it. Professor Halde was talking about atomic models. It was actually about the quantum mechanical model of atoms, and we learned about beta particles, which first showed that most of the atom is empty. Then it was like this: beta particles are emitted by nucleus. So there are neutrons and protons, and beta particles are emitted. But beta particles are negatively charged, and nucleus is positively charged. So I asked my teacher, how come negatively charged particle come from inside of the positively charged particle? And my teacher told me that neutrons and protons are not really fundamental. They're substructure. If you could zoom out and look inside there are actually some other things. Then I started asking those questions. What's really fundamental? I still don't know. I'm asking that question. That's my research area. And there were no universities in Ethiopia that offer a course in theoretical physics, so I had to join applied physics. That also added to one of the inconveniences I had. But fortunately, even within the applied physics, one of my professors had been to ICTP to attend the conference. And when I told him that I'm interested in theoretical physics, he told me that I should look out for ICTP. So since my second year in university, I was preparing to come to ICTP. Then I finally came to ICTP and experienced what the Honorable Minister experienced. It was like stepping into a new world. In Ethiopia, I didn't have friends to share my passion of physics with. Then I came to ICTP. My friend Isai from Peru, like we wait until we leave the classroom because we were excited about the very topic we learned it to discuss with each other. It was amazing. And it was very intensive. It was not simple. And my background was not strong. Even for students whose background was relatively strong, it was very difficult. It was very scary. But what got me through is, and what I appreciated about ICTP the most is that the people there truly believed in us and what they were doing. So it was not like they were having pity on us or showing compassion to people with no good background. So they believed in us. They were preparing us to be the next generation of scientists. They did not see it as a philanthropy or, I don't know words to explain that, but they really believed in us. So for example, I did my diploma thesis with Professor Atish Dabolkar here. So he told me like you should do this holographic entanglement entropy. You look at CFT on the side and gravity on that side. Then I told him, but I don't know CFT. How can I learn? Go read it. I read and I did it. And by the end of the way, before I say this, there was a T-shirt, one of the souvenirs of ICTP. There's a Lagrangian of standard model, all the physics we know, the universe as we know it now. So I saw it, but I did not want to buy as the first time I joined because I want to understand everything. Then I did 8 courses in 8 months, and by the end of the second course of standard model, I could do computation with every single term in the formula. Then, when we first joined, they recommended us that we go to colloquium, listen to the seminaries, but at first it was very daunting because it feels like not even language. It was something else. Then by the end of my program, I could talk to the speakers, ask questions, meaningfully contribute. My diploma thesis was on holographic entanglement entropy. One of the biggest discoveries of 21st century in high-energy physics is the fact that Professor Greg Gavadesh was saying about the late Jim Simons. that quantum entanglement entropy knows a lot. Like it's the first clue we had to understanding the very fabrics of the cosmos itself, of the space and time itself. So I worked on that. I really understood it. So I'm very happy. Yeah. The scientists at IP are engaged in cutting-edge research, and another incredible aspect was that the sheer number of scientific programs organized at ICTP. Through this, I had the chance of meeting most of my academic heroes, Professor David Gross, Eddie Witten, Ashok Sen, many Nobel laureates. And finally, to get back to international collaboration, what I said, Professor Haldin already said is the thing that resonated deeply with me. Also because whenever you walk into ICTP's building, so I was there for 365 days. So every single time I walk into ICTP building, the quote I see is this: scientific thought and its creation is the most common and shared heritage of mankind. So it's deeply ingrained in me. Fundamental science is a universal language, as many of the speakers were stressing already. And more important is that science is not a zero-sum game. No one should be left behind. We also need as many people as possible pushing the frontier of our knowledge forward. The fundamental sciences are now so advanced and hyper-specialized that it's virtually impossible to make progress by confining research to specific geographical areas. For example, I'm now based at MIT in the US, but my professor is Peruvian. I'm working with him. My first paper was with a student who is from Turkey. And my next project is going to be with a scientist from India. So we cannot really do physics now, as used to be the case within a confined area. We need global cooperation and the inclusion of as many voices and talents as we can bring to the table. Those talents could well be those that we did not know we needed. And I'm grateful to have been given the opportunity to be one of those contributing to that frontier. There is still, as we all agree, a lot to do. For example, I am the only black student and one of the only 2 African students doing PhD in physics at MIT. So I shared my highlights of my journey also from my background because I believe this is a typical situation of a student growing in developing countries, more specifically in Africa. And I truly believe there are millions of untapped talents around the world just waiting to be discovered. Thank you very much. I'm very grateful. God bless you.